Hi, we're team number 1 from group 505 and I'm going to present our team members.
My name is Mikel Rodriguez.
Hi, I'm Beto.
Hi, I am Masael.
Hi, my name is Osli.
So, to make an introduction about our lab practice, we first investigated about these different three types of gas laws: Boyle's law, Charlotte's law, and Gay-Lussac law. Each law describes how a variable changes when another measure is modified, while keeping some conditions constant. Okay, first we have Boyle's law that describes that the pressure of a gas is inversely related to its volume when the values are constant. Then we have the Charles law describes that when the temperature of a gas increases, its volume increases. And finally, we have Gay-Lussac law that describes that the pressure exerted by a gas is directly related to Kelvin temperature.
Purpose and research question. The main purpose of this experiment was answer the question, how the gas laws work. With this experiment, we aim to see how the gas laws work, so that we can better understand their function and how they are applied in everyday life.
In Charles' experiment, we thought that if we hit air, it will get expanded, and if we cool it, it will get compacted. That's why the balloon got bigger in hot water and smaller in cold water.
For our first experiment that it was about the Charles law, as an independent variable we had the air temperature, and as dependent variable we have the balloon volume of if it contracts or expands. And of controlled variables we had the size of the balloon and the bottle of water and the time we left it in the water. For our first experiment, we will be using a bottle of water, a balloon, a bowl with ice and water, and a bowl with boiling water.
To start with this experiment, we're going to use the bottle with the balloon, and we're going to place it in the boiling water. That is going to do that the balloon increase, and then in the ice water is going to decrease its volume. And the result for the balloon is that when we put it in hot water, it inflates, and when we put it in cold water, it deflates. This is because the air inside the bottle heats up and expands, and in cold water, it contracts.
In Gay-Lussac experiment, we thought that when we heat the can on the stove, the pressure inside will increase, but when we move it quickly to the cold water, the pressure will drop, and that's why the can got crushed.
For our second experiment that was about the Gay-Lussac law, we have for independent variable the heat of the can or the temperature of the can from the stove to the cold water, and as dependent variable we had the pressure inside the can. For controlled variables we had the can type and size, the amount of water inside the can, and the time we left it in the stove or heated time. For our second experiment, we are going to be using some tweezers, a cane, an empty cane,
First, we add teaspoons of water, approximately 5 milliliters. Then we turn on the stove. After that, we took the can with tweezers as a precaution and let the water boil. Finally, we place the can upside down in the cold water.
The result of the can is that the can contracts very fast when we put it in cool water. This is because when we burn the water inside the can, it makes steam, and when we cool it, the steam condenses into water, and this makes a low pressure.
And finally, in the combined gas experiment, we thought that when the air inside the bottle get cooled down, the pressure inside will decrease, and that's why the air was pushed into the bottle.
For the experiment that was about Boyle's gas laws, therefore independent variable we had the air temperature outside and inside the bottle, and for our dependent variable we have the pressure inside the bottle. For controlled variables we had the size of the bottle and the egg, the time that we placed the egg before heating the paper and the amount of paper that we heated. For our third experiment, we will be using a boiled egg, an empty glass bottle, some paper, and fire.
For our third experiment, we're going to fire the paper. Then put it this way and wait.
Creo que tenía que quemarlo un poquito más, ¿no?
The result of the egg is that it starts getting in, but it can't because the egg was too big. This happens because when we add fire into the bottle, we expand the air, and when we put the egg, the air cooled and contract. This made that the pressure outside is higher and pushes the egg into the bottle.
This experiment showed how gases work to change in temperature and pressure according to the three gas laws mentioned. In the first experiment, the balloon inflating head and disinflating cope, making us see that gas volume increases with temperature. In the second one, the can contracted because the cool reduced the inside pressure, allowing the outside pressure to crush the can.
Finally, with the third experiment, heating the temperature of the glass bottle with bond paper makes the boiled egg to inflate, since inside pressure lowers and outside pressure pushes. Some errors could have affected the experiments, like the egg being too large to fit in the cover of the bottle. Also, the experiments still show that these gas laws work correctly, and showed us that gas particles move faster in heat and move slower in cold. So this shows explains the changes in volume and.
To conclude, through these three home experiments that we made, we could observe how the laws of gases behave in real life situations. Through the Charles gas law, we confirm that air expands when it's heated and it contracts when it's cooled. With the Gauss-Lussac law, we saw the increase of temperature makes also increase the pressure, and it makes decrease the pressure when it decreases the temperature. And with the Boyle's law, we saw and we observed how it decreases in temperatures and reduces in pressures. These experiments were exciting because they help us understand the concepts we have seen in class visually and practically, and we also confirmed that our hypothesis of all the experiments that we saw was correct, and we learned about how the pressure, volume, and temperature are related directly with the gas laws. That's all for video. Thank you for your attention.